We're going to look at concave mirrors, and we're going to focus on when the image is between the focal point and the center. So for a concave mirror, it's essentially a spherical mirror, this being the center and the focus point or focal point being halfway from the center to the outside. It's hard to look at when it's a full circle, so we're going to get rid of the circle. And then we have our concave mirror. We have our three formulas on the side here. 2 times the focal point is the center. 1 over the focal point is equal to the distance of the object plus 1 over the distance of the image. And then magnification is equal to the height of the image over the height of the object. It's equal to negative the distance of the image over the distance of the object. If you don't quite understand or aren't able to follow all of those little variables there, here it is. You can pause the video and take a look at what each means. But let's say we have our image here. We're going to focus on when our image is between the focal point and the center. Okay, so we'll draw our image in. And let's say we have an image that's at the number 4. Okay, so it's about 4 units from the center, and we'll say it's 2 units high. Okay, so what that means is our object, okay, the distance of our object is 4 units, and the height of our object is 2 units. We also know, since the center is at 6, that the focal point is at the value of 3, and you can plug that into this equation here if you're unsure. Okay, so we can use this information to figure out the rest of what our image will look like, and then we can show, using the reflection of the mirror, how that works out. So our first form, or our second formula I should say, is 1 over the focal point, which is 3, over is equal to 1 over the distance of the object, which is 4, plus 1 over the distance of the image, which is unknown. Okay. So we have to isolate for distance of the image. We bring 1 over 4 over, it becomes negative 1 over 4 is equal to 1 over distance of the image. We need to get a common denominator. The quickest way to do that is to multiply the one fraction by the opposite one's denominator. So in this one we multiply by the 4, and this fraction we multiply the top and the bottom by 3. We end up with 4 over 12. Subtract 3 over 12 is equal to 1 over the distance of the image. We get 1 over 12, and if we were to quickly cross multiply, you'll get that the distance of the image is equal to the number 12. Right? We have distance of image times 1 is distance of image. 12 times 1 is 12. Okay, so we found another variable. It takes us to our third equation, the magnification. Okay? Magnification is equal to the height of the image over the height of the object. So equal to negative distance of the image over distance of the object. Okay, well, we had the height of the image, height of the object, which was 2. Distance of the object was 4, and we just discovered the distance of the image is 12. So we can use all the information. We'll call this the third formula. First of all, magnification, we can just set that equal to what we have here. So we have negative distance of the image is 12 over distance of the object was 4. So the magnification is equal to negative 3. So it's increasing in size. The magnification is equal to 3. And what we did there is we just focused on m equal to that, and we just dropped the middle of this equation. Now we're going to focus on what the new height of the image is. So the height of the image over the height of the object, we said, was 2. We'll plug that in. Is equal to, again, we have our negative 12, the distance of the image over distance of object, which is 4. So the height of our image is equal to negative 3, and again, that's over 2. And to isolate for height of the image, we bring over 2 and multiply. So our height of our image is equal to negative 6. So let's go back up. The distance of our image was 12. The height of our image was negative 6. So I don't even have 12 on here. It needs to be 11, probably about there. It's probably about where 12 would be from the distance of the mirror. And we said it was negative 6. So you're looking at an image that goes all the way down to here. Okay, so that's 12 units from the center of the mirror and negative 6 units downwards because it's below the x-axis. Now, using our Razr Reflection here, we'd first draw a ray directly to the mirror, and then going through the focus point, and that looks like it kind of crosses at the bottom. And now this mirror is a lot more concave, but we go to our focal point, and it should, if this mirror is drawn a little better, what should happen is you come across, and where the two of them cross will be the image is. Now, as you can see, this one really became curved at the end. A better representation would be something like this. Okay, and because again it became so very curved, the mirror would probably be something along there if it was drawn perfectly set. Whoops, let's not move that. Let's move this line here. There we go. And where these two cross is where our new image occurs. Okay, so the curvature of this mirror would be a little better if it kind of came out like that. Okay, that's generally how you do it. And again, these rays, one parallel to the ground and then reflecting back through the focus point, the other one going through the focus point off the mirror and then parallel again, and where the two of them meet would be where our new image would occur. Okay, so that's, and again, if you notice, the images, I guess we should speak about that, sorry. Along with that, our image, when we're between the focal and the center, our image is way past the center. And the idea is that, think of it, when we're at the center, our images are identical. When we pull the object this way, the reflected image goes closer to the mirror. When we pull the object this way, the reflected image goes farther from the mirror and gets larger, and in this case it gets smaller. And again, with that magnification, if you remember, our height of our image was 2. If we multiply our 2 by our -3, we get our new image, which is -6. So again, all of the math kind of works out there.